All right, so one of the things that we talked about prior to break was we said we could find greatest common factors, and I thought you guys did a good job with that. The other thing we talked about was differences of perfect squares, right? What made something a difference of perfect squares? You had to have three things in order to do that, right? You had to have, first of all, how many terms? Two terms. What do I have to be doing with those terms? Subtracting. And what did all those terms have to be? Perfect squares, right? So these four examples here are kind of tough because now I throw some fractions at you. But if you take the definition strictly, they're all DPSs, aren't they? How many terms? Am I subtracting? Is 1 perfect? What's 1 times 1? So is 1 perfect? Yeah. Is 4 perfect? Yeah. And is x squared perfect? Yeah. So this can be set up into one of those, right? What's the square root of the x squared? What's the square root of 1? And what's the square root of 4? So yeah, even though it looks like it's complicated, it's really not, right? Next one. Square root of 25? 5. Square root of x squared? And the square root of 9 is 3. Okay, with C. Square root of 4? 81. X squared? And then what? 7 thirds, right? And then the last one, a little bit easier. 6x plus 7y. 6x minus 7y. Are we okay with those? Yes.
Did you ever give us one that's like adding?
If I did, what would you say? You can't use this method, right? Yeah. So yeah, I mean, I've seen that show up, right? Where usually is an extension on what I'm going to show you right now, down here. Yeah, I'll show you what that looks like in a second, okay? Actually, let's do this, guys. Add this to the bottom. All right, so that was 4x squared plus 36, okay? So what are the directions here, guys? It says use a combination of GCF and DPS. And I want you to circle this and star this phrase right here. Completely factored form. Okay? When you see that phrase, completely factor, what that means is you might have to do more than one method, right? So make a note of that. This might be more than one method. You have one. You have the remote. You gotta have a remote. You want to try this one? See if this one works. Now, when you do this, guys, you are always going to do GCF first, and then 2, DPS. Do me a favor, Skylar. Come here for a second. This is the freeze button right here. Go over there and let's see if it'll work, or give it to him and tell him to try it. What do you think is going to happen? No, I won't. It won't freeze in here. All right, so the directions were to factor completely, right? Yep. So I got a 5x squared minus 20. I want to determine if it has a GCF. Can 5 be the GCF? Yes. Does it go into 20? All right, so in terms of a GCF, I know I have a 5. Can x squared be a GCF? No, because there's no what? There's no x squared over here, right? So just 5. Okay. Now, how do I get the stuff that's left over? I take the 5 and I do what with it? Ah, good. Yeah, so we got to remember this step. Take 5 and divide it into this. And what do I get? I get the x squared, right? Because the 5 and the 5 will reduce. And then 5 goes into 20 4 times, right? So the fact that I said completely factor means that the result or the thing that you create inside might be a DPS problem. Is x squared minus 4 a DPS? 2 terms, subtracting, all perfect. Yeah. So what do I have? I have the 5, and now instead of 1 set, I have 2 sets with a plus and a minus. What am I going to have? I'm going to have x plus 2, and I'm going to have x minus 2. So that was a 2-step problem. That was a GCF followed by a DPS. All right, how about in B? Can 28 be the GCF? No good. Can x squared be the GCF? No good. Can 7? Yes. Why? Because it goes into 28. All right, so 7. Take a second and write down what you think that next term is. All right, so if I took 7 and divided it into 28x squared, 7 goes into 28 4 times and leaves the x squared, right? That x squared is not going to just disappear, is it? All right. 7 goes into 7 1 time. Is 4x squared minus 1 a DPS? Yes, it is. 2x is my first term. Plus 1 and minus 1, right? That good? Can 40? Can 40 be it? Maybe. It's not that easy to figure out, right? 40 does not divide into 250, I promise you. What's the next factor of 40? Biggest? 20. Yeah. Does 20 go into 25? Well, does 2 go into 25? No, so no good, right? So 20 doesn't go into 250. What's the next one? 10. 10 goes into both, right? Okay. And then I have an x squared. Is that going to be part of my GCF? No, because there's no what? X squared here. So I have a 10. All right. 10 goes into 40 4 times. 10 goes into 250 25 times, and there's still the x squared that stays. All right, so now what? Now I got another DPS problem, right? Square root of 4 is 2. Square root of 25x squared is 5x. Cool? All right, part D. Does 3 go into 48? How many times? 16, yeah, so 3 is good. And then this is the first time that we have what? An x, right? Yeah, an x. Why not an x cubed? Because x cubed is bigger than the x, right? So I have 3x. This is a good question now. 3x goes into 3x cubed. Well, what happens to the 3's? Cancel. And x cubed divided by x leaves x squared. Yeah, what do I do, guys? When I do this, right? What's on the x? A 1, right? What am I supposed to do with the exponents? Subtract. You guys know why? Okay. What's another way to say x cubed? X times x times x. What's another way to say x to the first? X. Now what happens when you have things that are common? They cancel out. What's left? X squared. That's why you subtract. Right? That's why you subtract. Okay? All right, so we said x squared minus 16, and this x reduced, right? And now what do I have? X squared minus 16 is another DPS, right? So x plus 4 and x minus 4. All right, and I asked you guys to add part E, right? So here's what we got in part E. Is 4 GCF? Is x squared? So just the 4, right? And then what's left? An x squared plus 9, right? And this was kind of what Aiden was suggesting, right? Like, will you ever be given something where there's an x squared plus 9? You're probably never going to be given anything that says factor x squared plus 9. But you may be given something that says factor completely, where one of these shows up, where you're sort of lured into using a difference of perfect squares incorrectly, right? So this right here is not a DPS problem. And so we are done. Is that okay? All right. We're not going to complete the entire next lesson, guys. I only want to spend like 5 or 6 minutes because I want to give you guys some time to start some work, okay? So what I want to do here, guys, is I just want to get you into a skill that we're going to use the next couple of classes, okay? Guys, when you get one of these problems, right, this is factored. We understand that, right? What makes something factored? You have things that are being multiplied, right? Agreed? All right. So this is factored, right? So if I wanted to go back to your algebra class for a minute, what did you typically do with something like one of these? You double distributed, right? And there was a special name for that. Aluminum foil, right? So your teachers, right? You talked about, so I'm going to write down a couple of phrases here. You talked about double distributing, right? You talked about foiling. Did anybody talk about tic-tac-toe? Okay. To me, this is the best method, okay? It's the best method because it always works regardless of the number of things we're multiplying. And as we move on, we may look at more complex multiplication problems. If you don't know what tic-tac-toe is, I'm going to explain it right now. It's super, super easy. How many terms? 2. How many terms? 2. However many terms are here and however many terms are here always tells you how many lines you're going to draw. So I have 2 terms and 2 terms, so I'm going to do 2 lines down and 2 lines across. If I had 2 terms and 3 terms, I would do 2 lines and 3 lines. Cool? Now what you're going to do is you're always going to cross out that box. That box is not used in our method of tic-tac-toe. Then you're going to write down 3x plus 2 and 5x plus 7 here and here. Now it really doesn't matter which side you put those, right? You can alternate where you put them. And then what I have my students do is I have them draw a nice circle around these 4 boxes, because those 4 boxes are going to be my solution. What's nice about this, guys, is it's super visual, okay? And so sometimes when we FOIL, we kind of maybe make an error in the way we do it because we're sort of like skipping from one thing to the other and multiplying outsides and insides. And so it sort of gets confusing sometimes, especially when there's multiple things like 3x, right? What's 3x times 5x? 15x squared. Do you guys agree that this box is where those two things line up, right? Which two things make this box? 5x and 2. What's 5x times 2? All right, what two things make up this box? 3x and 7. What's that multiply to be? All right, and then what makes up this box? 7 times 2 is 14. Now you can take those 4 terms and add them together, right? And that is your solution, right? So we expanded this, right? We took the factors and we expanded it to make a trinomial, right? All right, we'll do the one below. All right, so again, my method of tic-tac-toe, I have 2 terms and 2 terms. I have 2x minus 3, and I have 2x plus 5. And again, my solution is going to be in the circle. Two x times 2x, 4x squared, good. 2x times negative 3, negative 6x. 2x times 5, and 5 times negative 3, negative 15, good. And then what am I doing? I'm taking everything in the green circle and adding it together, right? So I have a 4x squared. You guys agree I can combine 10x minus 6x? That gives me, and then minus 15. Now, when you're looking at this and you're seeing this technique used, raise your hand if you've never seen this technique used. All right, so you guys have all seen it before. Okay. The reason that I emphasize this is because what if I changed this problem over here? Let's change this problem. Let's make it this. Suppose I gave you that. Right? How's that different? It's a binomial times a trinomial, which means I have 2 things times 3 things, right? So if you listen carefully to the directions, I have 2 times 3, so that means 2 lines and 3 lines. This top corner still remains empty. And so now what do I have? I have 2 spaces here, so that's got to be the 4x plus 3. And then I have the 3 spaces here. And I know that my answer is going to be these 6 spaces, right? So 4x times x. Oops. And 4x times negative x is negative 4x squared. X times x, right? 4x times negative 1 is negative 4x. 3 times x squared is 3x squared. 3 times negative x is negative 3x. 3 times negative 1 is negative 3. So what's the biggest exponent I have in my solution? Cube, right? So I have 4 of those, so I have 4x cubes. And then I got a couple of squares, right? I have a negative 4 and a 3. What's negative 4 plus 3? Negative 1. So I have minus an x squared. And then I have negative 3x and I have negative 4x. Negative 3 and negative 4 is negative 7x minus the 3. Right? Who's seen one of these done with more than with 3 terms and 2 terms? You've seen this before. Yeah. So again, do we agree that it's a really nice method to keep our work organized and neat, right? And I prefer this over the foiling just because it is visual. How you guys doing? All right? Great. All right, I'm going to stop there. All right, I'm going to give you guys the rest of the